Yeah, that's good. Chris Chinnock here for Display Daily. I'm at IITSEC 2014 with Derek Dirks in the Daylight screen booth, where actually we just had a little conversation. And the reason this conversation started was because as I've been walking around the trade show floor here, there have been a number of laser phosphor projectors introduced. These can produce some speckle, but more importantly, they produce a lot of brightness. And there's always been a problem with projectors that are just too bright in the simulation market, especially in curved screens or dome screens. You get cross-light contamination from one side of the screen to the other. So I asked, does Daylight have a solution for this problem? And the answer is yes. So tell me about that solution.
Absolutely. Daylight, we've been creating diffusion coatings for rear projection screens for about 30 years, so we've got a lot of experience in that arena, and we've developed a lot of new coatings that are very high contrast, very wide viewing angles, and also handle speckle. So they're low speckle coatings for those newer projectors, newer light engines that introduce those artifacts. And those are quite widely deployed in the industry.
So it's almost a mix and match kind of approach. If I need a speckle coating, I add a speckle coating. If I need a cross-contamination coating, I add a low diffusion coating. I can do that.
Absolutely, that's correct. We have an entire team of chemists that will dial in a particular formula for you. So we have reference formulas to give you kind of a starting point, and then depending on your application, your projector that you're using, your resolution requirements, your contrast ratio, how much cross-reflectance you have, we can dial in both the substrate and the coating itself to be able to give you that optimum picture.
Now, you told me about a material that you developed over here. What was is there a model name or something for that?
I think the one we were looking at was most likely a half-gain coating. We don't have a marketing-friendly name for the coatings. They've got a very engineering-focused model number to them. But we like to keep them more flexible that way because it's easy to communicate to our customers and our engineers what they mean and how we can change them for their application.
But the point of that particular coating was if you put that, and we talked about, let's say, a 220-degree collimated display, a typical kind of application. Normally, in today's environment, you get a contrast ratio that's in the 10, 12 to 1 kind of range. With your coating, you can get up to closer, I think you said, to 30, 35 to 1.
Correct. So that is work that's in process to verify basically the contrast ratio for the full collimated system once it's assembled. So you have the interaction with the IG and the mirrors and other things within the system to give you that system number, which typically ranges, I've seen data here at the show of, anywhere from 8 to 1 to 13 to 1 on the high end. Our coatings themselves, we have coatings that range from 65 to 1 contrast ratio to over 100 to 1 contrast ratios, purely from the screen and the substrate and diffusion coating side of things. And then that's obviously going to come down once you introduce that into a system with a collimated mirror. It's going to start depending on other factors, but purely the screen itself is, from the industry data I've seen, is still multiples of higher contrast ratio than what's out there currently.
For sure. And what you're showing here is actually a back projection, a collimated screen, not quite exactly the configuration that you just described, but it kind of illustrates the concept. And this is all acrylic, so it can be molded into spheres, into toroids.
Correct. Yeah, so the example we have behind us is one of our standard coatings with a 65 to 1 contrast ratio, very wide half-angle viewing angle of, I believe, this one ranges from 40 to 69 degrees, depending on the gain of the coating, which we can also dial in from a range of 0.6 to 0.4, depending on what you need. So, yep, this is a good starting point for a BPS, and then we can also take that performance and ramp it up from here.
So with the advent of these higher lumen projectors, do you think you're going to see more of the need for this type of screen, and obviously good for your business?
Yeah, absolutely. It's one of the things we talk about a lot is we've been involved with the simulation industry for 20 plus years, but the real catalyst we see just even over the last couple of years and definitely going forward, is projection transition from CRT to digital and now to 4K projectors with solid-state light sources, introducing artifacts like speckle and other things going on, where the coding becomes much more important. With a lower resolution projector, you could maybe get away with some other things for codings, but now at that higher resolution, having minimal defects in the screen and having a very uniform coding becomes much more important, because we're showing so much higher fidelity images. You need to make sure that you're getting as much out of your projector and your beautiful glass collimated mirrors, things like that.
Exactly. Good stuff. Thank you very much.
Thank you.
Chris Chinnock for Display Daily.